Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning. Today I want to talk about trophic cascades and how top predators can shape entire ecosystems in ways that are not always obvious from a simple count of individuals. A trophic cascade is an indirect interaction that starts at the top of a food web and flows downward through one or more lower trophic levels. In many cases, a change in predator numbers alters herbivore behavior or abundance, and that in turn changes plant communities and even physical processes such as erosion or nutrient cycling. To make this concrete, consider two well-known case studies. First, take sea otters in kelp forest ecosystems. When sea otters are abundant, they eat sea urchins. With fewer sea urchins, the kelp canopy thrives, which provides habitat for fish and stores carbon. When otters are removed, sea urchin populations explode, and the kelp disappears. Second case comes from Yellowstone National Park. After wolves were extirpated, many herbivore behaviors changed, and riparian plants such as willows and aspens declined in certain valleys. After wolves were reintroduced, researchers observed changes in elk behavior and distribution, and gradual recovery of some riparian vegetation. When wolves returned to Yellowstone, the riparian vegetation such as willows began to recover because elk stopped browsing in the same places. Those two examples illustrate what ecologists call top-down control. Top-down control emphasizes that predators can regulate the structure and function of ecosystems from the top of the food web downward. This contrasts with bottom-up control, where primary productivity or nutrient availability limits higher trophic levels. It is important to remember that both forces can act simultaneously. In some systems, nutrient enrichment strengthens bottom-up effects and makes trophic cascades weaker, because abundant food for herbivores can compensate for predation losses. Ecologists test the strength of trophic cascades with a few complementary approaches. Long-term observational studies look at changes over decades. Exclusion experiments block either predators or herbivores from plots to observe plant responses. Stable isotope analysis traces energy flow and helps identify which species are actually consuming which resources. One phenomenon related to trophic cascades is mesopredator release. If top predators decline, medium-sized predators often increase and exert strong pressure on prey species such as ground-nesting birds. That is why the loss of a top predator can ripple outward in unexpected ways. Beyond the academic interest, there are practical conservation implications. Reintroducing or protecting top predators can be an effective restoration tool, but it is not a universal solution. Social acceptance, human safety, and land use constraints often limit what managers can do. Also, some degraded systems require active habitat restoration in addition to predator recovery. To summarize, trophic cascades show that species interactions can drive large-scale ecological change. We use case studies like sea otters and wolves, experimental methods like exclusion plots, and analytical tools such as isotope analysis to understand these dynamics. Recognizing top-down and bottom-up processes helps managers decide whether predator protection, nutrient control, or habitat repair will be most effective for ecosystem recovery.
Listen again to part of the lecture. Then answer the question.
When wolves returned to Yellowstone, the riparian vegetation, such as willows, began to recover because elk stopped browsing in the same places.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.